Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we proceed with next lecture, that is 2 and 3 force member. I, Aisyah binti Masyafi. Okay, previously we have learned about the rigid body, 2D and 3D rigid body, and also the reaction at the support or connections. And today we will learn about 2 force member and 3 force member. And today motivational quote is, the most precious gift you could give someone is to mention their names in your dua. Okay, for the introduction for 2 and 3 force members, if an animal has been or hinge support at both ends, so we have pin and support at both ends and carries no load, it's called 2 force member. So this element can only have 2 force acting upon them at their hinge. If only 2 force act on body that is equilibrium, then they must be equal in magnitude, collinear, and opposite in sense, they opposite in directions. So this is known as two force principles. The two force principle apply to any members or structure that has only 2 forces acting on it. This is easily determined by simply counting the number of places where forces act on the member. Okay. When a member is subject to no coupled moment and force are applied at 2 points on a member, the member is called 2 force member. So the criteria is equal in magnitude, collinear, and opposite direction. Okay, so this is the example of 2 force member. So for example here, this structure, there are forces applied at point A and point B, and these forces have F1, F2 and F3. This is the resultant. So we have FA here. So we have FA here and FB here, and the magnitude, the direction of this FB is negative FA. So this is this force FA and FB in opposite direction, and this one is collinear, so and have the equal magnitude. Okay, as I mentioned before, the 3 criteria is so the force are directed along a line. Okay, this one is compared to the force that result in couple both of the forces. For example, we have like this, and this one F1 and this one F2. Okay, if the situation like this, F1 and F2 has same magnitude, opposite directions, but it's have the distance of them is d, so this result in couple. But if the force are directed along a line that intersect at their point of application, so for example we have like this, and we have F1 here and F2 here, and this one is intersect at their point, and F1 equal to F2. So this one is a criteria for two force member. The difference is the distance, but for two force member it has the force act at the same line. Okay, so this is the important point for two force member. That is one of the unique aspect of these members is that the fact that the line of action of the resultant of the force acting on the two ends of the member must pass along the center line of the structure element. Yes, this is what I mentioned before, that must pass along the center line. And if they did not, the element will not be in equilibrium. Thus, even if the loading exists at either end that consists of only one of the component, the resultant of all the forces acting on two force member pass through the center of line. This means, okay, for this one, for example, if the loading exists at either end that consists of only one of the component, Fx or Fy, the resultant of, okay, this is for example, we have structure like this, and we have 2 points, and here this one is, for example, we have F1 like this, and this one we have okay, for example, here we have structure like this, and this F2 point here, and for F1 is at this direction, and we have two F1, F2 and F3. So the resultant of this is so this one is only one force, and this one is two force, but the resultant of this is opposite direction of F1. So that's why and this one, the resultant is pass along the center line of the structural element. And for three force members, if a member is subjected to only three forces, it is necessary that the forces to be either concurrent or parallel for member to be equilibrium. So before this is two force. We have two force that is same magnitude, opposite direction, and pass along the center line. And for three force member, it have three forces that either concurrent or parallel for the member to be in equilibrium. So to show the concurrency requirement, consider a body with any two of these three forces acting on it. So we have three forces here, and all of these forces intersect at O. So to satisfy moment equilibrium about O, the third force must also pass through O, which then make the force concurrent. So these all three forces are concurrent forces. And if the three forces parallel, the point or currency O is considered as infinity. So for example here, we have F1, F2 and F3, but these all three forces are parallel forces, so there are no center of point. So but the third forces must parallel to other two forces to intersect this point. So for this one, therefore the two criteria of three force member is the three forces must be coplanar and the forces must be either concurrent or parallel. So this one is the criteria for three force member. Okay, here is the example of two force member. Okay, some common example of two force member are columns, struts, hanger, braces, pin truss element, chains and cables stay suspension system. Okay, for example, here we have cable for lamp. It means I think most of you are familiar with this structure. There's at our building, outside of our building, we have lamp and we have this structure. Okay, here we have a lamp with the force to hold the lamp is 10 kilo 10 kilonewton, and we have point A. So this is because this one of the connections, and we have B here and C here. Okay, so this and we have F here. So there are two structure that connect to each other. So for this one, BC is two force member since forces act only at the B and C. So and this one we have okay, this one we have reaction here. For B, there are AY and we have BY and BX, and also at C we have CX and CY. So this one have the resultant we have resultant toward resultant like this, and also resultant like this. This resultant force of both forces act at the center of line. So that's why this two force is two force member. And for the same example, if three non-parallel forces act on a body in equilibrium, it is known as a three-force member. If a three force member is in equilibrium and the forces are not parallel, they must be concurrent. Okay, this is the criteria for three force member. And here, before this, BC is two force member, but here is we have A, C, and F. Okay, at A, C, and F, we have AX, AY, so 1 point of forces, and then we have C here, and also the forces of the lamp. So there are three forces at the between parallel to each other. So this one is a three force member. Okay, let's look for the first example. Okay, determines the reactions at A and D of the rigid body shown in the diagram. Okay, we have A, B, C, and D here. Okay, firstly, determine the. Okay, now let's look at the example. So here is the example of two force members. So the level A, B, C, we have A, we have A, B, C, and okay, we have level A, B, C is supported at the A and connected to a short link BD. BD is a short link. If the weight of the members are negligible, determines the force of the pin on the level at A. Okay, here we have force here and B and D. So how to solve it? Okay. Firstly, we remove the structure. This means BD and ABC. So for BD, short BD is a two force member. So the resultant forces at pin D and B must be equal. So this BD is two force member. So we have firstly it's like this, and the force here is same to the force here, and magnitude of the force is unknown, but line of action known as it pass through B and D. Okay, we don't know the value of F here, but we know where this force act is in the line of the same center line. And level A, B, C is a three force member. So here we have A, B, and C. Because there are 3 points that's member act. So this is three force member. So for moment equilibrium, three non-parallel forces acting on it must be concurrent at O. Force F on the level at B is equal but opposite to the force F acting at B on the link. Okay, here okay, this one we focus at B. B here is same point, B here and B here, but as we can see here, force at B is toward right, and force at B here is toward down. This force is same but opposite direction, opposite to the force acting on B. Distance CO must be 0.5 meter since line of action of F and the 400 kilonewton force are known. So okay, we have here 400 Newton and distance CO. Okay, we have okay, here is the CO. Okay, here is 0.5. Okay, this one is given. Okay, this one is given in the questions. So for the solutions, okay, first okay, here we have BD and ABC level. So for BD, because the F here is related to F here, so we need to focus on ABC 3 force member. Okay, here you can see like this. We have 40 newtons, and then this is at point C, and then at point B, F here, and at point A, and okay, this one just solve this equation based on 2D forces. Okay, here for the F here, okay, we have okay, firstly we get the theta because we want to use to get the component X and Y of FA. So theta is here, and this one is 0.7, and this one is 0.5. So the degree of theta is tan -1 0.7 over 0.4. Okay, sorry, this one 0.5 minus 1, okay, because we have 0.1 here, so 0.5 is until C. So if until A is only 0.4, okay, 0.4, so the theta is 60.3, and the component of Fx. Okay, for this one we have Fx here, Fy here, and this one is Fy, Fx. Okay, so for Fx we have here Fx, because it's toward negative x, it's negative F cos 45, and Fx for A positive Fa cos 60.3, and we also have 400 Newton toward positive. So this is first equation, and this is second equation for Fy. So for Fy here, Fay, and this one for F is negative, minus Fy equal to 0. and solving, you will get the force at A is 1.07 kilonewton, and we also can solve the force to get the F here. Okay, this is the example for the 2 and 3 force members. Okay, until now, that's all for today's lecture. So we will meet again for the next lecture. Thank you. Assalamualaikum warahmatullahi wabarakatuh.